Hello students. So this is your channel Bosons and I am KrishnenduKar. Today we will learn about the most important chapter from our class 11 physics, which is called vectors. Now if we want to learn about vectors, then we have to learn about another thing which is called scalars. These two quantities are very close to each other but distinguished and also have their own distinct meaning. So let's learn about this. What are scalars? Scalars are those quantity which has only value. Scalars are those quantity which has only value. Now what is vectors? Those which have value and direction. So let's give some example. So the examples of scalar quantities are like we can say mass. Mass is a scalar quantity, or you can say temperature. Temperature is a scalar quantity. Now why? You have to ask why is mass is scalar quantity and temperature is scalar quantity, and why force, velocity, displacement, these quantities are vector quantities. So let's understand this. Mass only have a value. Like let's say my mass is 50 kg or 60 kg. Let's say this marker pen has 200 gram of mass. Okay, but you can't give this marker pen a direction or its mass a direction. Mass is a quantity of matter. Okay, mass is a quantity of matter, right? And what is temperature? Temperature is something that indicates, let's say, the average kinetic energy. Let's not go deep into this, but temperature measures the how much heat it has absorbed or it has distributed or something like that. Okay, it indicates something like that. So so let's understand these quantities. Let's say this pen has 200 gram of mass. So what it implies? It implies that this pen has 200 gram of matter, 200 gram amount of matter. right? So now what is temperature? Temperature is something we measure in degree centigrade or degree Fahrenheit. It actually measures the average kinetic energy of each molecule. But let's not go deep into this now. We will learn about it later. But these two quantities, mass and temperature, does not indicate any direction. Okay? These two quantities, mass and temperature, does not indicate any direction. These two has only values. Let's say mass, 200 gram, 1 kg, 5 kgs, this type of values. Temperature, 100 degree centigrade, 0 degree centigrade, minus 273 degree centigrade, let's say 273 Kelvin, 0 Kelvin, and this type of quantities. Okay. But now let's say force, velocity, and displacement. Let's say I'm giving force the amount of like how much? 1 Newton. Let's suppose 1 Newton of force. This is too much, but let's say 1 Newton of force I'm applying on this board. Okay. Now, if you demonstrate this, you have to say in which direction. You know that you are applying 1 Newton of force on this board, but in which direction? I can apply this in this direction. I can apply in this direction. I can apply in this direction. I can apply in this direction also. Right? So, when I am mentioning about force, I have to mention its direction. In which direction I am applying the force. Okay? Let's say velocity and displacement. Let's say a particle moving from here to here. Let's say a particle moving from here to here. Okay, so what is displacement? Displacement, let's say a particle moving here to here like this, like this, like this. So there are two paths between point A and B. So which of them is displacement? Which of these two is displacement? I think the middle one and the shortest one. Because what is displacement? Displacement is the most shortest path between 2 points, right? So this one is the shortest path between 2 points. Okay. This straight line is not accurate because I am drawing it with my hand. But let's say it is a straight line. So this one is the shortest path and this is the displacement. But in this case, you can see that the direction of the path is changing. Probably in every and each point, it's changing, right? The direction of the path is changing in each point. But in this path, the direction is same throughout the path from point A to point B. So the middle one has a distinct direction, right? But the one I am removing right now had no distinct direction. It has a changing direction, right? So displacement has a unique and distinct direction. Let's say velocity. What is velocity? Velocity. What is velocity? What is velocity? Velocity is displacement divided by time taken. Okay? Velocity is displacement divided by time taken. So, we are considering displacement in the velocity. So, velocity must be a vector quantity. Right? Like you are saying some quantity is vector. So, if you are making another quantity with that quantity, then the new quantity will also be a vector, right? This is as simple as that. So velocity is also a vector, right? So we learned that scalar and vector quantity has a distinguished point between them, which is a direction. A direction differentiates between scalars and vectors. Scalar quantities are those which have only value, and vector quantities are those which have value and direction. And we learned about force, velocity, and displacement, how this is demonstrate the vectors and the mass and temperature. Okay, but let's say this is a line. Okay, this is a line A, B. Previously, if we are asked about this, we used to say that this is a line AB or this is a side AB. Okay. So, but because this had a value, it can be some centimeters or some meters. Okay, like 5 meters. Let's say 5 meters. Okay. But now we are considering directions in vectors, right? So if I put a direction in this line, if I put a direction in this line, and let's say a car moving from this point A point to B point. Okay. So the car is having a path from A point to B point in this direction. Now this AB is a vector, and whenever we are mentioning a vector quantity, there have to be a initial point and terminal point. Okay. So there's another thing, that is representation of vector. Representation of vector have two types. Okay. First one is line vector, and the second one is position vector. We have some other types of vectors like displacement vectors and all that, but these two are main. Okay, and in position vectors we can show it in 1D, in 2D, and in 3D. Okay, so position vectors can be represented in 1D, in 2D, or in 3D. Okay, the line vectors, we will learn about the line vectors in this video. We'll learn the position vectors in next videos. Okay, so these are the types of representation of vectors, and if we say this one is a line vector. Okay, and the thing is, vector represented as this. Okay, this is the representation or symbolization of vector, or we can say this one is A. Okay, this one is A vector, so we can say this one is A vector, right? So this is the whole representation of a vector. Now there's another thing called the magnitude or the absolute value or the modulus. So what is this? Okay, this is the value of vector. So the value of vector is called the magnitude, absolute value, or modulus. Okay, so we can call the value of vector the magnitude or absolute value or modulus of vector. Okay, it represented as like, let's say a vector. Okay, let's say a vector. So a vector between the modes. Okay, or we can say a b vector between the modes. Also it can be represented as like this: no arrow, no mode. Okay, we can write it like this. In your books, you will find that vectors are represented in the bold letters. Okay, like a could be written in bold letters, but we can't write it like that in our notebook or in our exam sheets. So basically, we represent it as just putting an arrow above it, and for the modulus part, we put a mod around it, or we can remove every symbol and just put the a to symbolize the magnitude or absolute value or modulus. Okay, so this is the representation of vector. Now we will learn the types of vector. There are kind of 9 to 10 types of vectors. Okay, this differs book to book. In some books, you will find that only probably 4 or 5 types. In some books, you will find 6 or 7 types. In some book, you will find 8 or 9 types. This depends totally on the author of the book. So let's say the types of vectors. So the first type we have is equal vectors. Okay, the first type we have is equal vectors. So what is equal vectors? Vectors having same value and same direction vectors having same value and same direction are equal vectors. Are equal vectors. Okay, let's say this two are, this one is AB, this one is CD. Say this one is small a and small b vectors. So we can write that AB vector is equal to CD vector. Why? Because we can see that AB has the same magnitude and CD also has the same magnitude, and both is in the same direction, like in this direction. Okay, or we can say A equals to B. So this is the equal vectors. Okay, and we can assume that there will be another type called opposite vectors. And you are correct that just write down it here and turn it. Why I am saying turn it? Because it will has the same value but opposite direction. Just opposite direction. Just turn it. Just turn it. Turn it 180 degree. Okay. So vectors having same value, or we can write now like same magnitude, same modulus, same absolute value, whatever we can write it. Same magnitude, but opposite direction. Okay. So let's say this is a b vector. So this is a vector. This is CD. So this is b vector. Okay. Now A and B have the same magnitude. So we can write A and B has the same magnitude. But these two vectors are not equal, right? Because they don't have the same directions. They are placed in the opposite direction in 180 degree phase difference. Okay. So now there is another subtopic in this, which is called negative vector, which is called negative vectors. So what is or what are the negative vectors? Okay. So negative vectors are those vectors which are just opposite in directions. Now, as we know that the magnitude of vector A and vector minus B are same, and we can see that the direction of vector A and minus B vector is same. So we can write that A vector is equal to minus B vector. Am I right? A vector is equal to minus B vector, because we can see that A vector's direction minus B vector direction. A vector's magnitude and minus B vector's magnitude, both are same. So we can say that both are equal vectors. Okay. So the next type of vectors we will learn are called parallel vectors, or we can say collinear vectors, and the anti-parallel vectors. Okay. Parallel vectors. So what are the parallel vectors? Now we have to think about something. Let's write the definition first. Vectors having same directions. That's it. That's the definition of parallel vectors. Okay. Vectors having same directions. Okay. So vectors having same directions can be this, and this, also this, there are three vectors and three of them is in the same direction. Three of them is in the same directions, right? So now we can say that AB vector is parallel to CD vector is parallel to EF vector. Okay. But we can also see that AB and CD are seems to be like equal vectors. Right? AB and CD are seems to be equal vectors. Okay. So we can say that AB and CD are equal vectors, first of all, and we can also say that equal vectors are a part of parallel vectors. Or we can say that all equal vectors are parallel vectors. But reverse is not true. Why? Because we can also see that AB and EF are parallel vectors, but these are not two same or equal vectors, right? Because EF has more magnitude than AB or CD. Okay, so these are not equal vectors. So the all equal vectors are parallel vectors, but reverse is not true, right? We have another thing that is called parallel transition or parallel shifting. Of any vector does not change the vector. So let's say here is a vector called AB. We are shifting it. We are shifting this vector from here to here. We are shifting this vector from here to here. Okay. So see that this one is parallel. This one is parallel. This called the parallel shifting, and this does not change the original vector. Okay. We will use this technique very often in many problems to solve them. Okay. So these are the parallel vectors. Oh, another thing, parallel vectors are called collinear vectors. Okay, collinear vectors. Parallel vectors are also called collinear vectors, and the most important thing is we see in many places the collinear vectors are mentioned as heading. So we have to remember that name also. Now, the next type of vector. Just like the opposite vectors, you can imagine that if there is a parallel vectors section, there will be an anti-parallel vectors section. Am I right? So vectors having opposite direction. That's it. That's the case. That's it. Vectors having opposite direction. Okay. Now AB and CD are anti-parallel. AB and CD are anti-parallel. And we can see that CD and AB both have the same magnitude, right? So we can say these are opposite vectors too, right? AB and CD are antiparallel vectors as well as opposite vectors. Now, AB and EF are not antiparallel. Why? Because they have the same direction. They have the same direction. Okay? But we can say CD and EF. We can say CD and EF are antiparallel. Are antiparallel. Okay? So this is the antiparallel vectors definition or whatever. Next, we will learn co-current vectors. So what are the co-current vectors? Vectors having same initial point. Vectors having same initial point. It doesn't mention the vectors has to be same magnitude or different magnitude. It doesn't mention the vectors have to be same directions or opposite direction. It just says that vectors having same initial points. Okay, so let's say this one vector, this two vectors, this three vectors, and this four vectors. This one is O, this one is A, B, C, and D. So OA, OB, OC, and OD are co-current vectors. Okay, so OA, OB, OC, and OD are co-current vectors. The next type of vectors which we'll learn about is called coplanar vectors. Coplanar vectors. So, what are the coplanar vectors, or which vectors are the coplanar vectors? The vectors which is in the same plane. The vectors which is in the same plane. These vectors are coplanar vectors. Okay. Let's say this A, B, C, D, E, F. So here A, B, C, D, and E, F are the coplanar vectors. Okay, because these vectors are in the same plane, right? This white board's plane, like this 2D plane. Okay, so these are the coplanar vectors. Now, the next type of vector is null vector or zero vector. This is nothing. Okay, this is nothing. The null vector and zero vector are those vectors which are the most often neglected and very much neglected vectors. Okay, because if we consider Like, let's say, let's first learn its definition. Vectors having magnitude 0. Vectors having magnitude 0. So if a magnitude of any vector is zero, then we can neglect it. We can neglect is vector form, because 0 is just a value, and if we multiply or add 0 with anything, we will get we will get nothing new. Okay, so null vector and zero vector have very low purpose in our calculation aspect or in our problem solving aspect. Okay, so we can write, let's say, vector A magnitude 0. This is the null vector. Okay, so we have some points regarding null vector or zero vector, which is the initial point and the final point are same. The initial point and the final point are same for null vector. So basically, they have no specific directions. And the second point is this type of vector have importance in just mathematical purposes. So this type of vectors have importance in just mathematical purposes. So note down the whole thing, pause the screen, take screenshots or whatever you are doing. Note down the whole thing. So this till now we have learned 7 types of vectors. Okay, we have only 2 of them left. Okay, I think you have noted down. So the next one is orthogonal vectors. Vectors having angle 90° between them. Okay, vectors having angle 90 degree between them. Let's say OA and OB. Okay, so OA and OB. So OA and OB are two orthogonal vectors because they have the angle 90 degree between them. Okay, this makes the two vectors orthogonal. Okay, now uh, oh, there's another thing we have to learn, which is angle between the vectors, which is angle between the vectors. Okay, so how we can calculate the angle between the vectors? Let's take some examples. Let's take another one, which is this. This one is AB. This one is AB, and let's take another one, which is this. Okay, so the first rule to measure the angle between two vectors or three vectors or whatever is we have to take their initial points as the same point. Okay, so the first rule is the initial points should be same. Okay, so if we make it same, now there's another thing which is called the parallel shifting or parallel transition. Okay, we have learned it. The thing is, if I take this vector to this position, this vector to this position, it is called parallel shifting. We are not changing its direction, we are not changing its magnitude, we are just shifting it. To another position. This is called parallel shifting. Here. So from this to this. Here we can see that the initial points are already in touched and a same point. Okay. So now there's another question. Which angle you should take? This one or this one? Which angle you should take? This one or this one? So the thing is, we should always take the smaller angle. This is kind of the procedure or the rule, or you can say this is this thing we do because for the sake of calculations. Okay, to ease the calculations, uh, take smaller angles. So this one is correct. This one is correct. Okay. So these are the procedure of measuring the angle between two vectors. Note down it and just pause the screen and note it down. Okay, done. Now we will learn the last and the most important type. The last and the most important type, which is called the unit vector. Okay. So unit vectors are nothing. Just like zero or null vectors, unit vectors are the vectors having magnitude 1. That's it. That's it. Okay. We can also say, let the notation, because unit vectors have their unique notations. Okay, it's not written as normal vectors like the arrow above the vector. Okay, so the notation of an unit vector along vector A, let's say A is a vector, okay, is this. Now see this n, okay, we can write A, B, C, D, whatever alphabet you want, but the symbol is this cap above that letter. Okay, this is read as in cap or in caret. Okay, mostly we use in cap, but in caret is also used. So there's a thing. See, in mathematics we saw that 12 equals to 1 into 12, right? We can write that, right? So if I say in cap modulus, there is 1. In cap modulus is 1, right? But we are saying that the notation of an unit vector along vector A is n cap. So n cap is in the direction of the vector A, right? So n cap is in the direction of the vector A. So we can say A vector and n cap vector are in the same direction. So n cap is giving the direction, and vector A, let's say the magnitude of vector A is this. So if we multiply it with this, we can get the vector A. Got it? Now, this is simple algebra. And this is the very important. And this is the very, very important formula. This is used to find an unit vector along any vector. This is the generalization or a formula. Okay, we can take B vector, C vector, or whatever vector is given in place of A. Okay, so to find the unit vector along any vector, we use this formula. We put the vector above and we divide it with its magnitude or absolute value or modulus, whatever you say. So these are the types or the By the way, you have paused it, right? You have noted down. So let's take a problem. Let's take a problem. This is very simple problem, okay? The basic one. Okay. So what is the angle between r vector and minus half r vector? Okay, let's find it. So see, minus half r vector is what? Minus half r vector is actually 1/2 times of the magnitude of vector r, right? This one have the 1/2 times of the magnitude of vector r, right? And also opposite in direction, because you can see that this one have the positive sign in front of it and this one have the negative sign in front of it, and both are r vectors, just opposite. Okay, so basically, therefore r and minus 1/2 r vectors are anti-parallel, right? You can recognize it, anti-parallel. They don't have the same magnitude, but they have the opposite direction. Okay, anti-parallel vectors. And I have mentioned it that anti-parallel vectors have the phase difference, or the angle between them is 180 degree. So the angle between them is 180. Okay, so note it down. Pause the screen and note down. Okay, so this is it for today, and we'll learn the next topics or the remaining topics in next lectures. So students, this is it, and let's meet in the next video.